Okay, we're gonna start the last section here. The last section is on what's called maximum minimum or min-max. It breaks into two categories. One is algebra questions, basically, equations, which we call absolute max and absolute min. And then there are word problems. The word problems are called optimization. So what we're going to do is I'm going to introduce max and min this week. We'll spend another week on max and min, absolute max and min, and then the following week we will do optimization. We'll do word problems. So we're going to put the optimization on the back burner. I might give you a couple examples to get ready for it, but for the homework this week, we're just going to worry about absolute max and absolute min. Now, having said that, it's actually philosophically easy. It's easy to get the idea. The problem is when we actually do it. I'm going to introduce the idea that has nothing to do with how we're going to do the question, but just to make sure we understand what we're doing mathematically. What happens is eventually we have to figure out when the derivative is zero. And then we're going to use that derivative of zero to figure out the max and the min. And that means there are three things that are going to happen in every question. First, you're going to have to be able to take the derivative right. So you're going to have to know your calculus. Then you're going to have to solve an equation. And when you solve that equation, you got to know your algebra. And then after you solve that equation, you're going to get some values, and you're going to have to put those values into the original equation and actually get the right number out. So you're going to have to do some arithmetic. So there's a lot going on in these questions. So while I say they are philosophically super easy to get your mind around what we're doing, the actual work is challenging, okay, for some people. So let me just go over the idea. The idea is this: we're trying to find the biggest y value and the smallest y value for each of these graphs, okay? So if you look at the first graph, it goes from 1 to 6, and it goes up, then it comes down, and then it goes up. And I think we all can see this. I think we all can see that there is the maximum value of the function, and there is the minimum value of the function, okay? And what you want to notice is that we can figure out what that is. The maximum, now this is important, this gets into the vocabulary. The maximum is 9, and the minimum is 2. So what we say is the absolute max is 9, and the absolute min is 2. The lowest it ever gets for y is 2, and the highest it ever gets for y is 9. And so we call that the absolute max is 9. And so you can see that, oh, that's pretty easy. Just look at the graph and you find the highest and lowest point. That is what we're doing, but we're going to try doing this without actually drawing the graph, just looking at the equation. So, but let's just make sure we got the idea. Because and you might, well, Ms. Pierce, this is really obvious. Why are you doing 5 of them? Because I'm actually heading somewhere with the ideas we're going to need to know for the math. Okay, so look at the next one. The lowest point is at 1, and the highest point is 8. So we're going to say that the absolute min is 1, and the absolute max is 8. So the absolute min is when y is 1, and the absolute max is when y is 8. Now you might go, which is where you're headed with this. Pay attention to where these dots show up, okay? Pay attention to where the dots show up. And I think some of you already figured it out, but let's just make sure we got it, okay? So if I look at this graph, the absolute min is again at 1. And that's, I drew these separately, and it wasn't intentional. Absolute min is 1, and the absolute max is 7. Now, one of the mistakes that students sometimes make is that they will say the absolute min is 4 or the absolute max is 9. No, that's where it happens. That's the x value. Remember, the actual biggest or smallest that the function is the y value. Okay, so make sure you realize that the maximum here is 7 and the 1. Now the 1's not because of that one, it's because of that one. Now let's draw next to it. And again, you hopefully can see where I'm headed with this. Okay, if you're paying attention, you might have figured it out. But don't worry if you haven't, I'll explain it in detail in a second. Next one. So when we look at the graph here, oh, that's weird. It can happen more than once, but that still means the absolute max is 7. There's only one absolute min and one absolute max. It can happen at a lot of x values, but the y value has only one absolute max, and then the absolute min here is at 1. Don't worry about the fact that I'm picking 1 a lot. That's just by accident. So the absolute max of this function is 7, the absolute min is 1. And then looking at the last one here, the absolute max is 10, and the absolute min is 0. Now, we're going to make some observations from this so that we can do the math, okay? Because this isn't what we do, okay? Because obviously if you have the graph, the question is trivial, okay? But I think by introducing this way, we get a feel for what we're going to be doing when we start doing the math, so you kind of remember, oh, that's what we're doing when we find the math. Here's what we're going to realize. First of all, this will always happen, so don't worry about this, but it's important that two things actually occur, okay? It must be continuous, and the function must be continuous on the closed interval. Notice I can't have any breaks in the function. Okay. Otherwise, it doesn't have to have an absolute max or absolute min, and it's got to be closed. Now, there's one exception to that. Oh, you can't see it. Let me put it on here. There's an exception. This is the main one. Okay, that it's got to be continuous on a closed interval. It can be actually continuous on a closed interval if there's only one critical number, and we're going to talk about that when we get to it. So I kind of put it off camera because that'll be like the last thing we talk about is, well, we don't have to have a closed interval. And this is going to get a little more philosophical than practical. You'll see that when we actually do the question. When we actually do the question, you realize I would have gotten the right answer if I didn't even think about that. But just trust me on it. There's a philosophical truth there that it can be open as long as there's only one critical number on the interval. Now, you probably realize I skipped the main part. Okay. I wanted to kind of do this first. So here's the conclusion of the idea before we actually do some examples of what your homework will look like. So right here, you guys, this is the big deal. Okay. Notice that this is it. This is it. If you could have fast forwarded to this point in the video, not going through all those figures. There are only two places that we have to look. Now, it could happen like multiple times, but there's only two places that the max and the min can be. It has to be when we have what's called a critical number, and that was what we were doing with our homework, or at the endpoint. Notice that, do you see that? Notice that the derivative here is 0. The derivative here is 0. Notice here, the derivative is 0. Or it's at an endpoint. I mean, that is it. And that turns out to be kind of important. Well, that was not shouldn't be circled. And that one, this was not right either. I'll put it back in blue here, but. Again, so notice that when we look at our red answers, that it's either the derivative is 0 or it's at an endpoint. The derivative is 0 or it's at an endpoint. Now, keep in mind, it's not all of them, of course. Those are when I create my choices, I'm creating a list of possible max and mins. But I don't have to check every point. Okay. Now, here's what, again, we're not going to do that often, but we'll do it enough that we have to talk about it. It's also when it's pointy. And this is when the derivative is 0 or it can be pointy. Well, let's take one going the other way. Let's do one min, one max. Or it can be pointy. So if the graph is either has a derivative of 0 or is pointy, it's a critical number. Now, when is it undefined? Well, the only thing that we have to worry about for undefined in this class is when we divide by 0. So either the derivative is 0 or there's some point where we're dividing by 0. And again, and that sounds like, oh man, how am I supposed to know that? Don't panic. The dividing by 0 will be pretty obvious, or so unobvious that it looks like we're multiplying by 0 when we're actually dividing by 0, but don't worry about that too much. We're going to focus basically right now on when the derivative is 0, and then I'll do one question at the end. So here's the thing. Overview. What we're going to be doing here is using calculus to take the derivative. Then that'll be the first step. We'll take the derivative every time. And then we're going to set the derivative equal to 0 and solve. Now, it might be undefined, but we'll worry about that when we get there. So we're going to have to do some algebra. And then after we figure out, now remember what the derivative being 0, well actually what we're going to do is we're going to find the 2 and the 4. We're going to find the 3 and the 5. We're going to find the 2 and the 4. What we're going to do is find the x values where that occurs, but then we have to put that back in the original equation to get the y values, and that's where we're going to have to do the arithmetic. So there's going to be kind of 3 steps. Now don't panic. I haven't done an example. I'm going to post this as the introduction to the course, but then I'm going to do an example of each one. Okay?